Surface Plasmon Resonance by Cal Hughes and Jake Wagner. So we did our project on surface plasmon resonance, or SPR, which is an optical phenomenon that occurs when polarized light strikes a metal surface at the interface between two media of different refractive indices. SPR results in a fraction of the incident light energy exiting electrons in a surface, such as a metal film, and causing them to oscillate. These oscillations are called plasmons. So as you can see here in this image on the right, when this laser is shined through this prism and onto the silver film back here at a specific angle, it is reflected, and at the very specific angle in here you can see a huge drop in the reflected light. All the light around it is being reflected, whereas that black strip is what is being absorbed, and that is what will be shown in our measurements later. The principle of SPR was first demonstrated in 1968, and then SPR imaging was introduced in 1988. And now we use SPR very widely to measure atomic and molecular interactions, and this technology is very useful in a number of fields, including but not limited to molecular biology, medicine, and material science. So setup and experiment. So we took a laser, set that incident on this rotatable stage here, made sure it was centered on it, as well as having the laser parallel with the table. We then put in 3 lenses. It's a little difficult to see here, but one lens way back here to really largely expand the beam. The second lens collimated that. And then this last lens very close to the stage here focused that beam back down onto the back here, or about exactly where the silver film will be placed. We made sure to make all these lenses perfectly normal with the laser. We did the same with the prism here. It's a little difficult to see here, the vernier scale down here, set that to 0, then adjusted the metal stage on top of it so that the prism was perfectly normal as well with the laser, locked that in. So now any changes we do down here to rotate the stage will be measured on the vernier scale, and we can get precise angle measurements. We then placed a P polarizer in the back here, right before the 3 lenses and right after the laser to polarize that light. So now after doing all that, we were left with this rotatable stage that we could turn, allowing the light to come in through here, reflect off over here onto the CCD camera. And the CCD camera will allow us to take a range of measurements rather than one singular measurement at precise angles at a time. With this prism, we would attach the silver film. Now this silver film was a little square of it that was attached on the back of a equally little square of glass, and this film and glass would be attached to the back flat wall of this prism using a oil that had a refractive index very close to that of glass. And also here you can see a screw here would push a piece on this stage up against the back of the prism so that it would hold the film perfectly in place and keep that exactly on the laser so that it actually is being reflected off of that silver and onto the camera over here. We would use this, and we could turn it a little bit using the computer that would be off camera over here to observe the light intensity measurements from the camera until we saw that drop in reflection that we were looking for. For analysis, we had 2 different thicknesses of silver film, one at 50 nanometers and 30 nanometers. We had many pieces of it, but those are the 2 sizes we had. And we made sure to try and take multiple measurements on using each different size so we could average those out and get a more accurate reading. For the 50 nanometer measurements, we were able to get 4 that were useful and good and showed a clear drop in reflection due to that SPR angle. Unfortunately, for the 30 nanometers, we were largely unsuccessful. We did get one that was pretty good. We then would plot these on the computer in a graphing software, and then we had to make sure we had the exact range of angles over here included in that graph. And the way we did that was we took a ruler, measured the distance from this flat side of the prism right where the silver film is all the way to the camera, measure that distance, and then use the distance. And there was a manual for the camera that had the exact width of the camera. Using those two measurements, we were able to use simple trigonometry and inverse tangent to calculate essentially half the range, the angle, so from the middle to the outside. And if we added that angle, for example, let's say that range would be 5 degrees to the measurement on the vernier scale over here, for example, 45 degrees, that would give us the range of, or add and subtract to the measurement over here, that would give us our range of angles over here. So in that instance, it would be a range from 40 to 50 degrees. Here are our results. On the left here, you can see our sole 30 nanometer measurements. You can see along the bottom here, we got the angle in terms of degrees. This one goes from 40 to 47, and over here we have our intensity range. And as you can see, there's a pretty huge drop at about 43.5. I think it was exactly 43.65 degrees is where our lowest value was. That's where the SPR angle was measured to be for this one instance. On the right, you can see our multiple 50 nanometer measurements very clearly standing out. We have our first one that we actually took, this very large outlier, which is at about 60.1 degrees, whereas these three hovered around 41, 42 degrees. Averaging these out, that gave us an angle of 46.76 degrees, which is a little bit high from what we would expect. In doing our research, we found that we should expect the SPR angle for silver to be about 44 degrees. So it's a little bit high, giving us a percent error of 5%. Removing this one and getting a few more proper measurements would have definitely helped level that out to what we would expect to see. And for the 30 nanometer, this is actually pretty good for what you would expect to see. As you decrease the thickness of the film, you would expect to see that SPR angle drop ever so slightly. And if with the angle even being averaged out at 46 over here, getting a 43.5 angle over here is pretty accurate to what you would expect. In conclusion, this experiment very effectively demonstrated the operation of SPR and how it can be used to measure these atomic and molecular interactions. Conducting this experiment, we were able to gain an understanding of how this phenomenon can be applied to a wide variety of scientific disciplines in order to conduct useful research. Thank you.